Okay, welcome to part 2 of the sheet metal sculpture lamp project design. We're getting ready to prepare our files for the flat layout, the DXF for laser cutting, and we'll show you how to do that in this video. In the last one we got about this far, and since then we've added a couple more of these crossbar pieces, but it looks like they're coming up a little bit short. And that's because these link arms sit on the outside of the other one. So our width between the upper link arms is actually a little bit wider than between the lower link arms. So these upper crossbars do need to be a slightly different piece. So let me go ahead and open those. We'll do a quick edit on these before we get things into our flat layout. And we'll come back to where they were originally drawn in our first sketch. And that dimension of 1.2 now in our upper crossbar needs to really be 1.32. We're adding another 120 thousandths or so to the width of that to span the gap between our upper link bars. And if our model is properly designed, everything should come right back and still be symmetrical for us. We'll just do a quick check from here to here, 0.21, and we'll do a quick measure from here to here, 0.21. So our model was nicely constrained in the sketches, so it all updated symmetrically. So I'm going to save as on this part to get a separate version. I'm going to call this lamp crossbar wide or upper crossbar, something like that. I think wide will help me remember which one this is, and do make sure you know what directory you're saving to. So I'll go ahead and save, and a document that has save as was executed on it has edits. It must remain open because it was referenced by other documents. Let's try OK to that. We are working on the new wide version here. If I close that here, yes, we have the older not as wide version here. Let me go ahead and close that as well. And in fact, I don't want to save it here because we do still need that narrow version for the lower link arms in our assembly. Since I've already saved as my edits, I'm going to say no to this dialog so that my edits are not kept on this file that's not the wide one. Alternatively, it's probably a better practice to copy that file in Windows Explorer before doing any edits. Let me hit our lightning bolt update, make sure we didn't break anything. I think we're back to where we were. Oh dear. And it looks like our lower crossbar actually somehow did save those edits. The good news is we've got the upper one and it's fitting in about how we would expect, but the lower one now is far too wide. So to remedy this problem, what I'd like to do is replace this component. Right click, component, and replace. With the, let's browse here for a second. Let's just get ourselves back there. There we have it. We're getting back into the lamp project. Let's go by modified here. So that is going to be our wide part between the upper link arms. So let's go ahead and replace that. Visually, it really doesn't look any different, but we see the name down here as wide. So I'm going to go ahead and do the replacement to this one as well, just so we have the proper names. I cannot emphasize as much, enough rather, how important it is to maintain proper file management in your CAD projects and proper naming of your files as well. And what have we done here? Did we replace it with the same part? Let's see what happened. This one seems to not be the wide part. I could have tried that replace all function, but since I'm already here. Okay, so I've got the two upper bars as the wide version. The lower ones are a different file now. They're still just as wide, but they are that separate file without wide in the name. So let me open those up. Let's get back to the first sketch, change that number back to 1.2 that it was supposed to be, finish it, come back to our assembly and update, and our upper crossbars are still wide and our lower crossbars are narrow. The narrow ones do not have wide in the name, and the upper ones do have wide in the name. You might notice some very minor discrepancies in how these fit. If we were to measure, there's a few thou difference here. It looks like we've stacked up to 9 thou now. We'd have to go hunt down that difference, but at the end of the day we're going to run a TIG weld over it, so that'll fill in nice and flat, and that 9 thou we're not too worried about. I think I haven't been real consistent in describing if we're using metal that is 60 thou thick or 63 thou thick. I think it's closer to 63 thou in real life, but nonetheless this should work out and fit okay with the tabs as designed. So we are ready for the main purpose of this video, which is breaking down our model back into a flat pattern. We've checked our design, everything fits and looks great, so we're ready to put it into a flat pattern. So this will work much in the same way as we did in Intro to Engineering for the Mini Sumo project. We are going to start with a new assembly, and into that new assembly we are going to place, and I don't have my project file set, that's why I have to keep browsing. Alternatively, let's open each part individually. So I have the link arm, I have the base, and back to the assembly I have the lower crossbar, which is just lamp crossbar V1 in my case, and I have the upper crossbar, and I'll open that. So if I were to tile my windows, I see that I have my brand new assembly down in this region where I'm going to be creating my flat pattern. Well, not to confuse terminology, it's not a sheet metal flat pattern. We are going to be manually creating a flat layout of our parts. We have the link arm, we have the base, we have the crossbar wide, and we have the crossbar. So I'm going to start dragging some of these parts into my new assembly from the browser over on the left. So it's just bringing that window into focus and dragging from the yellow block icon down into your assembly. So we'll get the wide crossbar, and we'll get the not wide crossbar. So these are the components that make up my lamp. I do need a duplicate of each of these, so I'll Control-C, Control-V, copy-paste. And I do need 4 of these, so Control-C and holding Control will go V, V, V. And they do insert where your mouse cursor is. I'd like to ground the, well, let's see. We have the link arm already grounded, so that is a fair basis for laying this out. Let's go ahead and constrain. We want to get them all flush, all onto the same level, going back to that grounded component. So one to the next or one to the original doesn't make much of a difference. We'll just get them all flush to each other, and we'll go to the cross plates. This can be very fast once you get the hang of it. Okay, and we have all of our parts planar now. Very important that none of them are rotated in some weird way. So we now need to just do a little manual nesting on our parts to get them all oriented for efficiency in manufacturing. And I'm looking at my parts with these angles. I think I may unground that just for ease of moving it around. Oh, and we're moving all the things now, to be expected, right? So that looks pretty good. Can we fit some of these in here? Do we save a little space by doing that? Oh, maybe I could turn those up. Let's look at this way. And I might just do the 3 across the bottom. Let's see, that's 2. Let me put one more up in there. Can I get 2 across the bottom? Not quite. Not a tragedy. We can maybe rotate it. Is there a precise rotate here? Not finding it. We could certainly constrain to something. So let's suppose we grounded the link arm and we constrain as an angle, as a directed angle between 2 edges, like that. So something like that is reasonable. And in fact, I might do the same for this one here. Let's suppose we ground this link arm. We don't need too many constraints. We just need them flat. We need them non-overlapping and with a little bit of space in between. And who doesn't like things that are parallel? Okay, so this is a pretty good material optimization, although we do want to, oh, that's kind of interesting. We might be able to do that. We just don't want to use more material than we have to in the few minutes it takes to put these together. Okay, so that's a pretty decent layout for ourselves there. That's not really wasting any material. You do want to keep a little bit of space. You don't have to go nuts and try to get it within 20 thousandths of an inch. You do want a little space so the laser is not double burning any one edge as it cuts out each part, and so that the remaining sheet still has some bit of structure left to it. Just quickly, I think I'll throw a sketch over this just to get an idea of how big this area is. Your parts should be fairly small in scale. If you're ever doing bigger stuff, our laser can cut up to 25 by 50 inches, though our sheets are typically 24 by 48 inches. You will want to make sure that whatever you're planning to cut in the entire area of your design can fit within the available sheet material that we have. Very important. And if you can keep them tight together into a row or into a square, even better. I did kind of the long ways on these. There are certainly other ways to have nested these parts together. And as I look at it, I'm really almost considering redoing this a little bit. Let's look at it for a quick second here. I'd like to get this into more of a square shape. So I'm just about 12 inches that way, which we can do, but it leaves you these awkward areas that's hard for other people to use. So if I back this up away from this sketch, what would happen if I were ungrounded? And I might regret this and come back to how it was, but what would happen if we did something a little more like this? Interesting. It's kind of like there's not a great way for 4 of these to nest. You could certainly do this. That arguably uses more material and put things in between. Like I said, might come to regret it. I think I'll go back to how I had these a moment ago, which was like this. Okay, it's looking good to me. I'm going to go ahead and save it. Everything's nice and together. Not a lot of wasted space. We'll go with that. Save. And it's in my lamp project folder. So I will save this as a lamp parts layout, and I'll go ahead and put a V1 on there in case I ever have to come back and do it again, and we'll save it. Okay, now there's a few more steps involved. We need to get this into a DXF file, which we cannot do natively from here. If you were doing it for one part and only one part, you could right click and say export face as. I don't think that's even an option in here. For an assembly, we need to do the intermediate step of creating a drawing. So let's do a new drawing, and you'll have to edit your sheet size to something similar to how big your part is, or your layout is rather. So I saw that mine fit within 12 inches. So on mine I think I'll do a 12-inch square. If your layout is exceeding a 12-inch square, I think we need to reconsider the design and size of your parts. We do want to be mindful of material utilization on this project. So we'll say OK. We don't need the border. We don't need the title block. All we need is the part geometry. Similarly, it's important that on our layout assembly, let's go back to it there, it's important that when you're looking at the front view that your parts are actually planar to the screen. If they're a little bit skewed like this, that's going to show up in your drawing. It's going to carry through to your DXF, and your laser cutting will be a mess, and your parts won't come out properly. So if you somehow moved a part, if you didn't keep that first one grounded and your front plane is skewed, let me just show you what would happen. So if this were your front view, and then in your drawing you brought in a base view of your front view, let's put that to full scale 1:1. What happens is you actually see a double edge on all of your features because it is not orthogonal to the view plane. So it's definitely something you must absolutely fix. Back on the layout assembly, if you do run into that issue, I'd recommend use this tool, which is the Look At tool. Look at the face, right-click on the view cube, say Set Current View As Front. That should bring you nice and square to where back in your drawing, once you update. Oh, interesting. That did not bring us back square. So the question is, what if we were to delete this view and bring back a base view of the front? Are we now square? It looks like we are. So when you place a view, that's important to note, it captures the orientation of the view at the time at which you place it, or so it would seem. So do make sure your assembly is good and flat to your view cube before bringing it into your drawing. So we're now in the drawing. The particular position here is not super important as far as I know. We'll have to check on that in Fab Creator software. But this looks good. Let's go ahead and we can save it if we ever had to come back to this. This is my layout V1. I don't know where I got the next one. Drawing. Yep. And let's go ahead and save copy as a DXF, drawing exchange format. This is the file type we need to bring into our laser cutting software, Fab Creator. Click Options. I'd strongly recommend bumping it down to AutoCAD R12. That tends to be the most universal, easily readable AutoCAD format for all other programs. So, AutoCAD R12, next, nothing we need to do here, and finish and save. Okay, and some things were happening in the lower left, so it's good to go. We can check in our directory. Whoops, let's switch folders here. Back to Principles of Engineering in our lamp project. We do see the DXF right here. If we wanted, we could open that in DWG TrueView. I usually just click Skip Association. I don't want anything permanent with which program opens that file type. So we can see our preview of our DXF in DWG TrueView. That's just fine. So all good, crisp, single lines, nothing else, no borders, no title blocks, just our part geometry, no thickness even, just our part geometry. So in this file, we have all the geometry for all the parts that should be cut at the same time out of the same material. Now I'm realizing as I look at this, for my lamp project and possibly yours, I'd like to do the base out of steel actually. So I may come back and redo this one more time to keep all the parts in aluminum in the same assembly, and then I'll go through the steps again for the parts I'm doing in steel. I want that weight down in the base. So I think I'll lose the base and I'll just sneak these up in this area and perhaps constrain them, oh, maybe parallel to here, something like that. That should work, and maybe I'll just get this one up here. Whoops, looks like the wrong thing moved on me. I think I may just ground that link arm. And let's try that once more as an angle. between two faces or two edges, and I might just put these here. I think that's probably, well, that's probably not our best material utilization. Let me rethink that. If we undo, what if we just brought them down here? That's probably less waste, and we'll just cut this long ways. Interestingly, I think the up, down, or left, right orientation does matter. On our laser, the left to right direction is the longer direction in our sheet cutting capability. So I may want to rotate this around this way, and then let's straighten these up a little bit. Not a big deal. And then let's reset this view. Let's make sure we're flat. Look at this. You can zoom it. Just don't orbit with your 3D mouse. Right click and set current view as front. Okay, let's come back to our drawing. That didn't update. Let's delete our view. Let's bring it back as a 1:1 scale. Very important. You don't want the parts tiny or huge. Let's say OK to that, and we need to just increase the size of our drawing sheet a little bit. Maybe, no, we don't really need the height, do we? But we do need the width. 16? Looks about right, and that's a pretty rectangular area. Leaves a lot of other area for other folks to cut their parts from. So we'll give that a try, and I'll just go through once more, saving a copy as a DXF. Check your options. We're going for R12. Finish it up. You can overwrite the old one and replace it. Okay, so that is creation of the DXF. Thanks for watching. In the next video, we'll show how to go through setup of that DXF in the Fab Creator software to generate the fab file for laser cutting that we can take right over to the machine on a USB flash drive. Thanks for watching, good luck with your project, and we'll see you in the next video.